Hi everyone! This video is going to be looking at naming organic molecules, and in this case we're going to be looking at molecules that have functional groups that will always fall on the final carbon. So we're going to find that these types of organic molecules aren't going to have any numbers in their name because we can always predict exactly where their functional group will fall. We're going to be looking at 3 different classes of organic molecules, again, all that can be found on Table R. So I recommend that you have Table R handy as you're watching this video. The first group that we're going to be looking at are the aldehydes. And the aldehyde functional group is this C double bonded to an O with an H, always found at the end of an organic molecule. To name these types of compounds, you're going to, again, look for the heart of the molecule. How many carbons are total in this particular compound? Since this one has 4, I'm going to use the prefix bute. I'm going to use the AN from the ane suffix to show that those are connected entirely by single bonds. And I'm going to use the AL ending that I found on Table R that denotes that this molecule is an aldehyde. It has the CHO ending at the end of its molecule. So let's use that pattern of naming to try and take a look at these next 2 molecules. Right here, I see that in total, I've got 3 carbons. So I'm going to be using the prefix prop to name this molecule. Those carbons are connected by single bonds, so I'm going to use the AN of ane. And notice that you can see the aldehyde functional group right here. Now it is at the sort of beginning of the molecule, but remember that these things are 2D representations of 3-dimensional molecules. So we could flip this thing over and make it really look like it's at the end. But what's important is that, yes, this shared carbon that's part of the functional group and part of my 3-carbon chain is going to make so that the end of the name of this molecule is AL. So let's break down another name and see if we can draw the molecule itself. I'm going to try and highlight my prefix, my bond number, and my ending to try and draw this molecule. Meth tells me that I've only got 1 carbon. There's nothing fancy about it. It's got all single bonds, but I can't even really draw that in right now because there's nothing to bond it to. This AL ending tells me I need to stick on my aldehyde functional group. And I know that that means to the last carbon, which happens to be the only carbon in this molecule, I need a double bonded O and an H. If I fill the rest of this molecule in with hydrogens, I find that it's only missing 1. So that ends up being my representation of meth and al. Meth tells me 1 carbon, the an tells me it's single bonds, and the al tells me put in that functional group on the last carbon. The second class of molecules that I want to take a look at are the organic acids. And right in the name, it tells us that these molecules are going to be slightly acidic. And that's because they are H+ donors. They give off H+ in solution. And it's going to be this last H that is easy to fall off of this particular molecule. To name these types of acids, we again need to talk about how many carbons are total in the molecule. That's where my bute comes from. The fact that they're all connected by single bonds gives me an an. And then I'm going to use the oic acid ending that I find on my example name on Table R that tells me that I've got an organic acid functional group at the end of my molecule. And sure enough, here is that COOH that's characteristic of organic acids. And yes, note that this C is part of the functional group, but also part of my total carbon count. So let's use those naming regulations to try and figure out the name of this molecule right here. I notice that there's only 1 carbon in the molecule itself, so I'll use the prefix meth. I'll stick with an to tell me that there's nothing really fancy about that, no double bonds around between carbon atoms. And then I'm going to use my oic acid ending because I see my COOH functional group right there. So that's going to make my ending become oic acid. So again, I can break that down into meth for 1 carbon, and for the single bonds, and oic acid telling me that I've got my OOH on my final carbon of the molecule. Let's take a look at one more example and try and break down the name to get to a structure. I'll highlight the fact that I've got a prop meaning I've got 3 carbons to draw. 1, 2, 3. The and tells me that those are all connected by single bonds. And again, the oic acid must be the modification, so I need to stick on my oic acid or organic acid functional group at the end of the molecule. Fill in the rest with hydrogens, and you've drawn yourself propanoic acid. So again, make sure you're breaking down this name into its pieces to know what's your base carbon chain going to look like and what functional group do you need to add on. We've got one final class of organic molecules to look at for things that we know will always come at the end of the molecule, and that's the amides. And amides are named in a very, very similar way. We've got 4 carbons shown in this molecule, so again, I use the prefix bute. Those carbons are all connected by single bonds, so I'm going to take the an of the ane suffix. And table R tells me that amides have the ending amide, believe it or not, and we're just going to stick that ending right onto the end of the name of the molecule. And the amide functional group looks messy, but what you're looking for is a carbon double bonded to an oxygen, and that carbon also needs to be connected to a nitrogen atom. So if we look at this structure here, what I see are 2 total carbon atoms, so I'm going to use the prefix F. I'm going to use AN to denote that those 2 are connected by single bonds. And then I need an ending to show that this functional group is part of my molecule. And again, C double bonded into O with the N tells me I have an amide, and my table R example name tells me that the ending for any amide is just amide. So F for 2 carbons and for single bonds, amide to denote that my modification is putting on this functional group at the end. So let's break down one more name. I see hex, I see an, and I see amide. So let's draw all those pieces. Hex tells me 6 carbons. An tells me connect them with single bonds. Amide tells me on my last carbon, make sure you stick on the O, the N, and keep that N happy by putting 2 H's at the end of it. So on my final carbon, I should see that functional group. If you fill in the rest of the molecule with hydrogen, you're going to have been able to draw hex and amide. Hopefully breaking down the names and structures in this way will help you name these terminal carbon functional groups.